So I'm going to talk on testing the waters, or how to tame the alligators and make sure you empty the swamp. And that button didn't work. Let's go for that one. So I'm Tom, also known as TB Sliver online. I'm a developer at Shadowcat Systems, but I also do DevOps, system administration. My mouse has just moved. Come back here, you. Project management, and basically anything else that Mark throws at me, which is quite a lot of random things. But one thing I do a lot of work on is large projects with multiple moving parts, lots of submodules, specific requirements for security and various bits and pieces like that. Wow, this is going faster than it should do. Let's go back a second. There we go. Come back here. And with any large system, you have to obviously be sure that things aren't going to break. Blur, where am I? Yeah. Sorry about that. Any large system, being sure that changing something doesn't break something else is always useful, but not always something that's actually been implemented. Of course, I'm talking about testing, but sometimes something I keep coming across is a lack of tests. And I get a variety of excuses, and this is literally what they are. They can't be tested, setting everything up is hard, maintaining the tests is difficult, or we just never got around to it. The last one is very common, but I find the other ones happen about as regularly, almost as regularly. You know, like if half of them never got to it, the rest of them are shared quite evenly between the other three. So in this talk, I'll be going over some of the ways I've made testing easier for other developers and made sure there's no obstacles to making sure that the code we've just written won't break. So what I'm going to cover here is a fairly simple example, extrapolate it on it slightly, and then take a look at some of the other setups that I've put together and tools that have helped make this easier. Note that a lot of these examples, come back here, you. Note that a lot of these examples are going to be web server and database style systems, although most of these principles can be passed on to other ones. So I'll be using Mojo and stuff like that for my tools, my modules. But if you've got something that uses a GUI front end, a lot of the principles at least can be passed over to that. So something I've been working a lot with recently is Modulicious and Modulicious based apps. And one of the things that is really, these are really easy to test. Test Mojo takes a lot of the hard, complex setup of user agents and getting everything to just tie together and go. So if you have a basic app, then the tests are basically as simple as that. It's a very basic example. So let's start adding something to make this useful. First off, we need a database, but wait, we can't or shouldn't use our main development one, as the test will stamp all over it. So how do we sort out a configuration file first for getting this disk to spin up? Now we could just create a config file specifically for testing and just have that in your repo, and then force it to use it with the envars. However, this does limit you later on whether you want to set something up custom or need to point at multiple different databases or have something spun up specifically for each test. So we're going to start with creating a temporary file. Come here, you. And then populate it as we need. Now, Modulicious, like most web frameworks, takes an envar for setting the config path. So here we can create a temporary file, just using file temp, throw a normal config file and tell it to use an SQLite database in memory. Now, at the end of this, you'll see a file seek 0 seek end. That's because, for some reason, either Modulicious or one of the models doesn't actually reset the config file to the beginning to reread it when it's with the file handle. So it kind of gets confused. Took a while to debug. I think it was the flushing to file. Modulicious kept thinking the config file was empty. But anyway, the next step for that is to set this as the config. So you can set the env mojo config to your file name, and there you go. You can now continue testing as before. Just to be sure, I'm making sure that the config DSN is what I expect it to be. This is one of the nice things about Test Mojo is you can reach directly into the application itself as if you were in the code, instead of having to put in extra hooks and stuff. Like, if you were running a pure Web Simple app, or if you were trying something completely insane. So now we've got a way to get a config for the database. The next is to actually add some data. So now you've got a database, let's push some stuff to it. I'm going to assume dbig here, but you can use basically anything for this, including raw SQL if you so desire. So let's assume we have a simple table of fruits and a new endpoint to get them from. So we'll get fruits which have an ID and a name and an endpoint of /fruits on your API. So we need to deploy a database and then put some data in it. Now, and that will return JSON. So this is what you can do. So you could just grab the schema object in your application, deploy it, and then populate it directly in there using normal debug method of populate. It's getting a bit longer, but it works. So then we can add another test and make sure that the endpoint JSON you get back is exactly what you expect it to be. So it's not as much of an issue here. There's only a small amount of tests. But if we change anything in our database, we now have to go back and change our tests. And if you've got 1,000 with this one test file, it's fine. But if you've got 1,000 test files and 500 different changes of various little tweaks to the database, this is going to get tedious very, very quickly. And also, this test is getting a lot more boilerplate. You've got to do your deploy and everything, and population all at the top. So let's move some of this out. So let's pull out the initial config file into a separate framework. So there's a lot of code on here, but this is mainly just because it's Moo and I've written it as clearly as I can. But we've got config file and Mojo attributes. So the config file itself is the file temp and printing out the part we need. And Mojo returns us the setup we need with the test Mojo on there in our class. And okay, it's taken more code here, but this has taken all of that code out of your tests. So it's taken 15 lines out of the test and replaced them with 2, which, if you've got a lot of tests, that adds up quite quickly. At 2 lines, we now have our test framework up. And also, if you ever when you need to modify something, so you need to put an extra config line in, you modify it in your framework, and then you're ready to go. When I press right, it should do the thing. So that's what the new initialization looks like. Much, much shorter. However, we still have the database population to sort out. Now, there is actually a tool around for that. Let's see. We have dbix class fixtures. What this module allows you to do is create a flat set of flat files on disk which represent your database, and given a schema or a DDL file, you can actually recreate the whole thing for you. With a bit of thinking, you can actually have multiple data sets. So you could have a data set which is just your users, an empty database just to see what happens in that case, a data set where you've got a corrupted user, for example, or a data set with far too many things you need. Now, when you've got a large system, something like this is a lot more useful. Something as small as this application is, it's a little bit overkill, but then again, may as well. If you have it set up at the beginning, it saves you a lot of time later on having to retrofit this in. So let's have a look at what this does for the fixtures. So the first bit you need to do is creating your fixtures. So in this, we have a directory for the configs. Where's my mouse? Haha, there's a pointer there. So we've got a directory for your fixtures, which is just in your current working directory. Normally in I normally put it in T, etc., or you put it in etc. fixtures. The schema, deploy your schema, and then here at the 3 dots, you push your data in. So that's where you do your populate task for putting all the data in you need for this data set. Pull out your data set name, and then dump it all into the correct file with the schema, and that will just dump everything to flat files, and it's actually raw Perl files, so you can go in and edit them. It's just a file that returns a hash, which is quite useful if you need to make more. You just copy them over, change the variables you need to, and continue on. With a bit of thinking, you can use this actually for not just one database, but 3 at once. My record so far is a test framework that spins up 3 Postgres and 2 Oracle databases at the same time to actually give you a full test framework. That was kind of hectic. Getting that to even work was a pain, because Oracle just doesn't seem to have a way of installing on anything. You have to use their VM, basically. It's a pain, really. I don't know why they do that. I don't know why people use it. But yeah. If you're doing that, then you just have to modify stuff like your fixture path. So you could add an extra database name, so fixtures /data/ I don't know, PG1 dataset. So then keep it consistent, so it's always the same for every single one of your datasets. And then what I end up doing is I put this file itself into my repo, because then if I need to recreate it, it's a very simple case of change it. And if I need to create a new dataset, copy, paste, redo the populate, and it's ready for next time. I think I end up with like 5 or 6 in there with just various little bits you can use. So with the fixtures created, then you just need to do the population from the config. So this is inside your framework. I've got some attributes for the etc. there. Because you've got obviously relative paths in Perl is a pain, because it's always relative to the place you've run it or the script, and if you're using find bin, you can only call it once in the entire process. So a lot of the times I do it as I pass it in exactly where it should expect the etc. to be, which fixture you want, and then pull out the fixtures config for yourself. For the actual directory, and then pull out the data files itself. Then we just create the dbit fixtures attribute. Pop the dbit. So this is again in your framework. Pull out create a new dbit class fixtures. Pull out the config dir for it. Return your fixtures object, and then in your Mojo bit, you deploy your database, and then you populate from your fixtures dir with that schema, and then return your test Mojo, and you have a database up and running, done, with all your data in. So let's modify our test to actually include it. And all this has done is add 2 lines to set where the etc. dir is and your fixture name. So if you've got multiple fixtures, you just change that for each one, done. And now if you ever need to change your data, you use your original populate script, or if you change your schema, use your original populate script to create the new fixtures set, and then all you've had to do is change one file, run a script, commit all the changes, and all your tests should continue running. Obviously, if you've changed any keys and stuff, if you're actually doing database testing in there, then you will have other bits to fix, but you've not had to fix your main for it. You've not had to go through and refix all your boilerplate in every single test. And so just saved yourself an absolute massive time. Now, obviously, this example uses a Modulicious app as a basis. But you can obviously easily modify this to run for something like Catalyst, PSGI, or even Apache-based applications. Say if you're using something that runs in mod Perl or raw or CGI, or something that relies on the Apache 2 modules. So for those, you have to pull out some more tools from my favorite toolbox, which is CPAN. So the other modules that you've got available for doing PSGI testing, you can actually use LWP protocol PSGI, which then allows you with a which overrides the LWP backend to actually use a PSGI app instead of the actual normal HTTP requests. You can also get it to do overrides with particular paths or particular host names. So if, for example, you want to do an offline test, but you want to use google.co.uk or something like that to actually, as part of your test framework, you can fake up a PSGI app that does what you want it to do for your tests and just get it to work automatically. Another one I use a lot, test MySQLD, spins you up a MySQL instance just for your test in a temporary directory. Don't need to do anything else. Don't need to use any pre-configured one or have it set up at all beforehand. Same with test PostgreSQL. That does exactly the same as test MySQLD, but for Postgres, and both of those support stuff like clustered setups. So as long as you've got the enough knowledge on how it all works, you can put that all together. And note the capitalization on test PostgreSQL. There is one where it's all lowercase. That's a very old version. For some reason, I don't know if it's a bug in CPAN or it's actually meant to be like that. But the one that's capitalized is the latest version, and the other one I don't think works anymore, or has some very odd bugs. And the final one is a module of mine, test instance Apache. And what this allows you to do is spin up an entire Apache instance for yourself in your tests. So you can use that as the front end if you rely on an Apache internals or something like that. This was basically done out of annoyance of Apache test because, well, Apache test is a pain in the arse, and it's mainly for writing modules for Apache rather than testing applications that rely on Apache. I don't know how it works. I still don't understand the documentation, so never mind. So I'll do a quick example of LWP protocol PSGI. It's a very useful one to know. Anything can be turned into a PSGI object can actually be used with this. So anything that runs under Plack, anything that, pretty much every single web framework on CPAN, and in fact, even in other languages, some of them can actually be turned into PSGI apps. So if you can get a PSGI app wrapper for, say, a Python app, you can put it in. This is just the changes I've required for doing in the framework for running against a WebSimple application. So create your new app there, populate the database, and then when you create, so instead in Test Mojo, you actually get your user agent for free. Here you have to actually create your user agent. So here, creating your mech, and here you do your LWP protocol PSGI register, pass in your app as a PSGI app, and then return test were mechanized new. And that has actually just overridden the backend for that, and any test you run on there will show up through your PSGI app. So if you really need to do odd things, you can do some very, very, very odd paths and things. I think I've had 4 PSGI apps up at once doing various things and testing across multiple instances. So otherwise, the test is very similar. There's a few differences between Test Mojo and were mechanized, but functionally it's almost identical. You know, you do mecha, pull out your mech, do a get against, check the contents are okay, check against /fruit, decode your JSON of the content, and check that it's right. Almost identical test. So I've got a minute left. I don't think I'm going to get through this, the last couple of slides. But if you want, I'll quickly show one of these. For MySQL, test MySQL, PostgreSQL, Postgres, external system you can work with, as long as you can sort out user rights, non-colliding names for multiple people to be able to run their tests at the same time. You know, using timestamps and their username is probably a reasonable starting point. Here I'll use an example for test MySQLD. Instead of using it, so This will spin you up a MySQL instance with no networking or crap itself. Plan your tests and then just connect your database as required, and that can be thrown into your framework just before you create your config file or into another attribute, and then you can actually use that to spin up your database as you start. And the Postgres example is almost identical. So I'm actually out of time. So I will skip the test instance of Apache, but if you want to see it,
we do have time for questions.
We've got time? Oh, okay, we've got time. We've actually got time for questions, so I thought I was actually out of time completely, but never mind. Any questions? Yes?
When you do the whole, like with test MySQL or test PostgreSQL, those take a long time, right, to spin them up. So if you have a large test suite, how do you handle that with multiple test files? Do you put it like up front and spin up one and then just get rid of all the data for every test?
So the question is, do I, with test MySQL or test Postgres, do I spin up a separate instance for each test, or one instance at the beginning, and does it take much longer? So yes, it takes much longer. No matter what you do, you're spinning up an entire Postgres instance. It does take like maybe 5 seconds a test to spin up a new one, depending on how complicated your schema and stuff is. You can do, if you think about it carefully, you probably could do a single testing instance and then test against that. Again, it just requires a bit more thinking. This is a very simple way of, I'm just going to spin up a new Postgres instance for each test and be sure it's right. You could do things like spin up a Postgres instance initially, and then rsync the entire base directory, or MySQL, I think this does work for. Spin up the MySQL instance, stop it, copy the entire file system underneath it somewhere else, run your tests, revert. Run your tests, revert, because you can do a file copy a lot quicker than you can spin up an entire MySQL instance. So that's one way of doing it, and you could already have it pre-populated with the data before you copy your files around. That's actually something I want to do when I get to writing test instance MySQL, but time is an illusion. Lunchtime doubly so. Any other questions? No? Okay. So the code examples that I used in this are actually available on my GitHub, tbsliver/testingthewaters. If you see any bugs in it, feel free to send pull requests, ask me questions at all on there or anywhere else. Thank you for watching. And you can find me, well, basically everywhere as tbsliver. Twitter, IRC, website, GitHub, everywhere else. Thank you very much.